What if I told you that everything you know about space exploration, every rocket, every satellite, every footprint on the moon, was just the prologue? What if our journey into the cosmos wasn't just about reaching the stars, but about surviving in ways we've never imagined, solving challenges that could change not just our future, but the future of life itself? And here's the real question. What if the destiny of humanity isn't decided here on Earth, but out there, on a barren planet, millions of miles away? Could Mars be the lifeline that saves us all, or the greatest risk we've ever taken? From the Cold War that sparked a race into orbit, to the very real possibility that someone watching this today could one day call Mars home, this isn't just a history lesson, it's a story about the future of you, a future that might depend on choices we make right now. October 4th, 1957, just another day, right? Until it wasn't. That evening, the Soviet Union launched a small, beeping sphere into space, Sputnik 1. It didn't look like much, a polished metal ball about the size of a beach ball with 4 antennas sticking out, but when it reached orbit, everything changed. That little satellite sent shockwaves across the globe. For the first time in human history, something made by human hands was circling the Earth from space. Imagine the reactions, people looking up at the night sky knowing that somewhere out there above them was a Soviet satellite. It was a massive wake-up call, especially for the United States. The Soviet Union had beaten them to space, and in the context of the Cold War, that wasn't just a technological achievement, it was a sign of power, a display of dominance. Suddenly, space was the new battleground. Archival footage of Sputnik's launch shows Soviet scientists cheering while across the ocean, American newspapers were in a frenzy. World leaders quickly realized that space wasn't just a curiosity or a scientific endeavor, it was a new front in the Cold War. The question on everyone's mind was, what's next? Could the Soviets send more than just satellites up there? Could space be militarized? The stakes couldn't have been higher. Sputnik didn't just capture imaginations, it lit a fire under governments, particularly in the United States. Within a year, NASA was born, and funding for space exploration skyrocketed. Suddenly, it wasn't just about who could build the best rockets, it was about winning the future. And behind this incredible moment in history were two key figures. Sergei Korolev, the Soviet Union's secretive chief designer who masterminded Sputnik and much of the Soviet space program, and Wernher von Braun, the brilliant German engineer who had defected to the United States and would lead NASA's rocket development. These two men, though on opposite sides of the Iron Curtain, were about to shape the next chapter of human history. Fast forward a few years from Sputnik, and the world was about to witness another milestone. One that would push the boundaries of what we thought was possible. April 12, 1961, a day that will forever be etched in history. On that day, Yuri Gagarin, a 27-year-old Soviet cosmonaut, became the first human to travel into space and orbit the Earth. It was a stunning achievement, and for a brief moment, the entire planet held its breath as Gagarin's spacecraft, Vostok 1, soared above us all. But who was Yuri Gagarin? Before he became a global icon, Gagarin was a farm boy with a love for planes. He grew up in a small village, and his path to becoming a cosmonaut wasn't exactly straightforward. But once he joined the Soviet Air Force, his determination and quick thinking caught the eye of Soviet space officials. He was handpicked from thousands of hopefuls, not just for his skill, but for his cool-headedness, charisma, and humility. The Soviets were desperate to beat the Americans again, this time in putting a human into space. The space race was as much about prestige and influence as it was about science. Gagarin underwent rigorous training, endless simulations, tests in isolation chambers, weightlessness exercises, you name it. And on that fateful day in April, all of that training culminated in one historic flight. As Gagarin orbited the Earth, his voice crackled back to mission control. "I see Earth. It is so beautiful." Those words, simple but profound, resonated with people everywhere. For 108 minutes, Gagarin was more than just a Soviet cosmonaut. He was humanity's first representative in space. The Soviets had pulled off another stunning victory. and Gagarin became an overnight hero, not just in the USSR but around the globe. The impact of Gagarin's flight on Soviet morale was enormous. It was a direct message to the world. The Soviet Union was the leader in space exploration. The political and ideological weight of that moment can't be overstated. It wasn't just a technical achievement, it was a symbol of Soviet strength, and for many in the USSR, a moment of immense pride during the tense Cold War era. But beyond the politics, Gagarin's flight captured the imagination of people worldwide. For the first time, humanity had physically left the confines of Earth and ventured into the cosmos. It made people wonder, if we could send a man into space, what else could we achieve? While the Soviets were celebrating Gagarin's historic flight across the Atlantic, the United States was facing a new challenge: how to regain their footing in the space race. And that challenge came directly from the highest office in the land. In 1961, President John F. Kennedy stood before Congress and issued a bold statement that would change the course of history. In his now famous speech, Kennedy declared, "I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth." It was an ambitious goal, especially considering America had barely managed to send astronauts into space at that point. But it wasn't just about science or exploration. For Kennedy, the Apollo program was about proving that American innovation, determination, and ingenuity could outpace Soviet technological dominance. The stakes were high and the entire world was watching. The journey to the moon wasn't smooth, far from it. The Apollo program faced its share of setbacks, the most tragic being Apollo 1 in 1967. During a routine test, a cabin fire broke out on the launch pad, killing astronauts Gus Grissom, Ed White, and Roger B. Chaffee. It was a devastating blow, not just to NASA, but to the morale of the entire nation. The tragedy forced the space agency to take a step back, reevaluate their approach, and make safety a top priority. But the setbacks only made the triumph that followed all the more extraordinary. Apollo 8 became the first mission to orbit the moon in 1968, and in July 1969, the world held its breath as Apollo 11 prepared for its historic mission. Astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins made the journey, with Collins orbiting the moon as Armstrong and Aldrin descended toward the lunar surface in the Eagle lander. And then, on July 20th, 1969, something truly remarkable happened. Neil Armstrong stepped off the ladder and onto the moon's surface, uttering those now legendary words, "That's one small step for man, one giant leap for mankind." Think about that for a second. After millennia of looking up at the moon, humanity finally had a presence there. Those words captured the spirit of not just the mission, but of human exploration as a whole. It was a statement that despite all our struggles on Earth, we are capable of achieving the seemingly impossible. Technically, the Apollo 11 mission was a masterpiece. The precision required to land on the moon, the coordination between astronauts and mission control, and the reliability of the technology were staggering. They had just one shot to make it work, and they did. The moon landing was more than just a scientific achievement. It was a defining moment in human history. For those watching around the globe, there was an overwhelming sense of awe and pride. It wasn't just an American victory, it felt like a victory for all of humanity, but the emotions ran deep. People gathered around their televisions, rich, poor, young, old, and watched as two men walked on the moon. The sense of unity, wonder, and possibility was tangible. For a brief moment, the boundaries that divided us on Earth seemed to disappear as humanity collectively reached out toward the stars. The Apollo program had its struggles, but in the end, it fulfilled Kennedy's bold promise and became a testament to what humans can achieve when we set our sights beyond the horizon. After the triumph of the Apollo moon landings, it might seem like the only way forward was to keep pushing farther into space. But, surprisingly, the next big step wasn't about going further, it was about staying longer. With the moon missions completed, NASA turned its focus towards something new. Skylab, America's first space station, launched in 1973. Skylab wasn't about quick trips to the moon or planting flags, it was about understanding what it takes to live and work in space for extended periods. The shift from the Apollo program to Skylab marked a new chapter in space exploration. Instead of short, high-profile missions, NASA wanted to explore long-duration space habitation. What happens to the human body when it spends months in space? Can we conduct science in microgravity that we can't do on Earth? Skylab was designed to answer these questions. Over the course of 3 missions, American astronauts lived aboard Skylab for up to 84 days at a time, conducting experiments, repairing the station, and studying how space affects everything from bones to plants. These missions laid the groundwork for what would eventually become long-term human presence in space, such as the International Space Station. But Skylab wasn't the only big story of the 1970s. Amid the tensions of the Cold War, something unexpected happened. American and Soviet crews joined forces for the first time in space. It was called the Apollo-Soyuz test project, and it marked a turning point not just for space exploration, but for international relations. In July 1975, an American Apollo spacecraft and a Soviet Soyuz capsule launched separately, only to meet in orbit, dock, and form a unified crew. It was a remarkable moment. 2 superpowers, locked in a bitter Cold War on Earth, were working together in space. The significance of Apollo-Soyuz was more than just technical, it was symbolic. This mission showed the world that space could be a place of cooperation, not competition. The American and Soviet astronauts shared meals, exchanged flags, and even learned each other's languages in preparation for the mission. While tensions on Earth continued, Apollo-Soyuz was a brief glimpse of what humanity could achieve when we put aside our differences. The docking of those 2 spacecraft became an emblem of détente, a reminder that even in the darkest of times, cooperation was possible. Looking back, Skylab and Apollo-Soyuz set the stage for the future of space exploration. These missions were about more than just science, they were about paving the way for international collaboration. The lessons learned from working together in space would carry forward into the future, culminating in global projects like the International Space Station. And at the heart of it all was the realization that space exploration doesn't belong to any one nation. It's something that requires cooperation, innovation, and a shared vision for what lies beyond. As the 1980s dawned, space exploration entered a new phase with the introduction of one of NASA's most ambitious projects, the Space Shuttle. First launched on April 12, 1981, exactly 20 years after Yuri Gagarin's historic flight, the shuttle was a game-changer. Unlike the Apollo spacecraft or the Soviet Soyuz capsules, the Space Shuttle was designed to be reusable, making it the first of its kind. This wasn't just about getting astronauts into space. It was about doing it frequently, bringing down costs, and opening up new possibilities for what we could achieve in orbit. The shuttle had unique capabilities. Its large cargo bay allowed it to carry heavier payloads than any spacecraft before it. Satellites, scientific instruments, space station modules, if it needed to go to space, the shuttle could get it there. But beyond its size and power, the real innovation was its ability to return to Earth, land on a runway like a plane, and be prepped for another mission. This meant more launches, more missions, and more opportunities to advance our understanding of space. NASA's vision was bold: regular trips to low Earth orbit, more scientific experiments, and even the construction of a permanent space station. Over the next few decades, the shuttle became synonymous with space exploration. It launched countless satellites that power modern communications, weather forecasting, and Earth observation. One of the shuttle's crowning achievements was the deployment of the Hubble Space Telescope in 1990. Hubble revolutionized our understanding of the universe, capturing breathtaking images of distant galaxies, nebulae, and stars, all thanks to the shuttle's ability to carry it into orbit. Perhaps most importantly, the shuttle played a critical role in building the International Space Station. Piece by piece, shuttle missions ferried up modules, laboratories, and supplies, turning the ISS into the massive orbiting outpost it is today, a symbol of global cooperation and the future of long-term space habitation. But the Space Shuttle era wasn't without its tragedies. On January 28, 1986, the Shuttle Challenger launched for what seemed like a routine mission. Just 73 seconds into the flight, tragedy struck. The shuttle broke apart, killing all 7 astronauts aboard, including Krista McAuliffe, who was set to become the first teacher in space. The world watched in horror as the explosion played out live on television. a stark reminder of the immense risks involved in space travel. NASA spent 2 years investigating the disaster and rethinking its approach to safety. Unfortunately, that wouldn't be the last heartbreak. On February 1, 2003, Columbia, another shuttle, disintegrated upon re-entry, again claiming the lives of 7 astronauts. A damaged heat shield, unnoticed during launch, allowed superheated gases to breach the shuttle's structure as it re-entered Earth's atmosphere. Both tragedies brought the dangers of space travel into sharp focus, underscoring just how fragile human life is in the harsh environment of space. But despite these losses, the Space Shuttle program remains one of NASA's most remarkable achievements. It pushed the boundaries of what we could accomplish in orbit, paving the way for the incredible advances we've seen in space technology. The shuttle wasn't just a spacecraft. It was a workhorse, a bridge between the early days of space exploration and the collaborative international missions that define today's space efforts. From launching satellites to assembling the ISS, the shuttle left a lasting legacy, one built on triumph, innovation, and hard lessons learned. As the 2000s began, space exploration was poised for another revolution. This time, not driven by governments, but by private companies. For decades, space had been the domain of NASA, the European Space Agency, and other government-run organizations. But all of that changed with the rise of private space exploration, led by ambitious entrepreneurs like Elon Musk and Jeff Bezos. Their vision wasn't just about launching rockets, it was about transforming the entire space industry, making space more accessible, affordable, and, ultimately, sustainable for future generations. Let's start with Elon Musk. In 2002, he founded SpaceX with a bold goal to reduce the cost of space travel and make humanity a multi-planetary species. Musk's vision is nothing short of extraordinary. He believes that colonizing Mars is essential for the survival of humanity. According to Musk, we need a backup plan in case Earth faces catastrophic threats, whether from climate change, asteroids, or other unforeseen disasters. And Mars, he argues, is the best candidate for that second home. But before we can even think about sending people to Mars, we need cheaper, reusable rockets. That's where SpaceX started to change the game. In 2008, SpaceX's Falcon 1 became the first privately developed liquid-fueled rocket to reach orbit. This achievement wasn't just a technical milestone, it was proof that private companies could do what only governments had done before. Then came the Falcon 9 in 2010, and everything changed again in 2015 when SpaceX successfully landed a Falcon 9 booster back on Earth for the first time. The idea of reusability, something that had once seemed like science fiction, became reality. With reusable rockets, SpaceX was able to cut costs dramatically, bringing down the price of launching satellites, cargo, and even humans into space. In 2020, SpaceX achieved another monumental breakthrough, the launch of the Crew Dragon capsule, which successfully carried astronauts to the International Space Station. This was the first time a privately built spacecraft had done so, and it marked the beginning of a new era in human spaceflight, one where private companies can ferry astronauts to space. For NASA, this partnership meant they could focus on more ambitious missions, like returning to the Moon or planning for Mars, while companies like SpaceX handled low Earth orbit transportation. The rise of private space companies has huge implications for the future of space travel. By reducing the cost of launching payloads and astronauts, companies like SpaceX are accelerating the timeline for exploring Mars and building permanent habitats in space. What used to be the exclusive realm of superpower governments is now becoming an open frontier for private enterprise. And with each breakthrough, we get closer to making space travel not just a rare event for a few, but a regular part of human life. These companies are pushing the boundaries of what we thought was possible, and as a result, we're entering a new space race, one that could take us not just back to the Moon, but all the way to Mars and beyond. What started as a few private ventures has turned into a movement that's reshaping the future of humanity's presence in the cosmos. We're on the cusp of a new era, and this time it's not just about exploration, it's about creating a sustainable future in space. As we look toward the stars, one of the most remarkable achievements of the modern era is the International Space Station, or ISS. Launched in 1998, the ISS stands as a beacon of international cooperation in space exploration. Unlike any other project in history, it brings together space agencies from around the world, including NASA, Russia's Roscosmos, the European Space Agency, Japan's JAXA, and Canada's CSA. This collaboration has not only advanced our scientific knowledge but also forged partnerships that transcend borders, politics, and national interests. Each country contributes unique capabilities and expertise to the ISS. For instance, Russia has provided the initial modules and much of the operational experience from their long-standing space program. The European Space Agency brings a wealth of engineering and research with contributions like the Columbus Laboratory, which is vital for biological and physical science experiments in microgravity. Japan's Kibo module offers a space for experiments that require external exposure to space, while Canada's Canadarm2 has become essential for assembly and maintenance operations on the station. The ISS is more than just a scientific laboratory, it's a precursor to long-term habitation in space. Over the years, astronauts and cosmonauts have lived and worked aboard the ISS for months at a time, conducting experiments that study the effects of microgravity on the human body, testing life support systems and exploring new ways to grow food in space. These experiments are critical as we prepare for longer missions, such as trips to Mars, where resources will need to be managed efficiently and sustainably. Imagine a future where humans live and work on Mars for extended periods. This requires us to solve many of the challenges we face on the ISS today. For example, managing water and air supplies, recycling waste, and growing food in closed-loop systems are all essential skills we need to master. The ISS serves as a vital training ground for these missions, helping us understand what is possible and what still needs to be figured out. But perhaps the most profound aspect of the ISS is how it has laid the groundwork for future multinational missions to Mars. The partnerships formed on the ISS have created a framework for collaboration that we can carry into deep space. Just as the nations involved in the ISS have learned to share resources, technology, and expertise, future missions to Mars will require even deeper cooperation. A project of that magnitude, sending humans to another planet, will demand contributions from around the globe, pooling the best minds and resources from every corner of the Earth. So as we celebrate the achievements of the ISS, we should also look ahead with optimism. The lessons learned from this incredible cooperative venture are setting the stage for our next great leap into the cosmos. With nations coming together in common purpose, we are not just aiming for Mars, we are building a future where humanity can thrive beyond our home planet. The sky is no longer the limit, it's just the beginning. With the advancements made in space exploration and international collaboration, our sights have increasingly focused on Mars, the next frontier for human exploration. Over the past 2 decades, NASA has ramped up its efforts to explore the Red Planet with a series of remarkable rovers that have fundamentally changed our understanding of Mars. 2 of the most significant missions have been Curiosity, which landed in 2012, and Perseverance, which touched down in 2021. Curiosity was a game-changer in many ways. This rover was designed to explore Gale Crater, seeking signs of ancient life and examining Mars's habitability. One of its key findings was the discovery of organic molecules and evidence of ancient riverbeds, which suggested that Mars once had the right conditions to support microbial life. Curiosity was equipped with a suite of sophisticated instruments, allowing it to analyze soil and rock samples, conduct atmospheric measurements, and even take stunning high-resolution images of the Martian landscape. The information it collected has given scientists invaluable insights into Mars's geological history and climate, setting the stage for future missions. Then came Perseverance, often affectionately called Percy. This rover took the exploration of Mars to the next level, focusing on searching for signs of past life and collecting samples that could eventually be returned to Earth. Perseverance is equipped with cutting-edge technology, including the MOXIE experiment, which is designed to produce oxygen from the Martian atmosphere. Imagine that, a machine creating breathable air on another planet. This technology is crucial for future human missions, as it would allow astronauts to generate oxygen for breathing and even for rocket fuel. Perseverance has also been tasked with testing other technologies to prepare for human exploration. One of its key goals is to analyze the Martian environment and assess whether it can support human life. It's conducting experiments that will help us understand how to live off the land, like producing water and utilizing local resources. This rover isn't just a robotic scout, it's paving the way for the first humans to set foot on Mars. They are part of a broader strategy to bring Martian samples back to Earth. NASA and the European Space Agency are collaborating on a mission that could launch in the late 2020s, with the goal of retrieving the samples collected by Perseverance. Analyzing these samples on Earth could provide answers to questions we've had for decades about whether life ever existed on Mars. In summary, the work of these rovers is essential not only for our understanding of Mars's past, but also for the future of human exploration. Each discovery, each experiment, builds our knowledge and confidence, bringing us closer to the day when humans can walk on Martian soil. As we continue to send robots to explore the Red Planet, we're setting the stage for a historic moment in human history. A moment when Mars will no longer just be a distant dream, but a tangible reality. As our understanding of Mars has deepened, so too have our ambitions for sending humans to the Red Planet. A significant influence on this vision comes from Dr. Robert Zubrin, an aerospace engineer who has been a tireless advocate for direct, cost-effective human missions to Mars through his innovative concept known as the Mars Direct Plan. Zubrin's idea emerged in the 1990s at a time when many were still envisioning complicated and costly missions that could take decades to realize. In stark contrast, Mars Direct proposed sending humans to Mars using current technology and a much simpler approach. Instead of relying on vast fleets of rockets and complex logistics, Zubrin suggested a straightforward plan: send a crew to Mars on a single spacecraft, utilize the Martian environment, and return to Earth using resources found on the planet itself. A key component of this plan is in situ resource utilization, or ISRU. This means leveraging what Mars has to offer to sustain human life and operations. For example, Zubrin envisioned producing fuel from the Martian atmosphere, which is primarily composed of carbon dioxide, and extracting water from the Martian soil or ice deposits. By using ISRU, astronauts could create the fuel needed for their return journey and generate oxygen for breathing. This approach not only reduces the amount of material that must be launched from Earth, but also makes long-term human presence on Mars far more feasible. Zubrin's vision resonated with many in the aerospace community, including NASA and SpaceX. His emphasis on a straightforward, practical approach to Mars missions has influenced discussions about how to get there sooner rather than later. For NASA, Zubrin's ideas have contributed to the development of their own plans for human exploration of Mars, emphasizing the importance of technology that can be developed and tested on the ISS before being applied to Mars missions. Moreover, his advocacy has had a significant impact on public perception. By presenting a clear and compelling argument for how we can reach Mars, Zubrin has inspired countless enthusiasts, scientists, and potential future explorers. He has ignited a sense of possibility and urgency, shifting the narrative from "if we can go to Mars" to "when we will go to Mars." His ideas have helped to rally support from both the public and policymakers, generating enthusiasm for a human mission to Mars. In many ways, Dr. Zubrin's Mars Direct Plan encapsulates the spirit of exploration. It's bold, it's innovative, and it's grounded in the reality of what we can achieve with the technology available today. As we continue to push the boundaries of space exploration, his vision serves as a guiding light, reminding us that the journey to Mars is not just a distant dream, but an achievable goal that is well within our reach. As we enter a new decade, the dream of colonizing Mars is becoming increasingly tangible, largely thanks to SpaceX and its ambitious plans for interplanetary travel. At the heart of this vision is Starship, a fully reusable spacecraft designed not just for missions to Mars, but for a variety of tasks, including launching satellites, ferrying astronauts to the Moon, and even facilitating travel around Earth. Starship represents a revolutionary leap in space transportation technology, and its capabilities could redefine what we believe is possible in human space exploration. So, what makes Starship so special? First and foremost, its reusability is a game changer. Unlike previous spacecraft that could only be used once, Starship is engineered to be reused multiple times with minimal turnaround. This drastically reduces the cost of space travel, which is a crucial factor for ambitious missions like colonization. Imagine being able to launch a rocket that can carry 100 tons of cargo to Mars. This opens up incredible possibilities for building infrastructure and supporting a human settlement. The design of Starship is sleek and innovative, crafted with stainless steel to withstand the extreme temperatures of both launch and re-entry. Its Raptor engines, powered by liquid methane and oxygen, are designed for efficiency, enabling not just Earth launches, but also refueling in space and potentially on Mars itself. This is essential for a sustainable human presence on the Red Planet, as it allows for in-situ resource utilization, essentially turning local resources into fuel and life support systems. Elon Musk has been vocal about his Mars colonization plan, laying out a timeline that aims for the first crewed landing in the mid-20s. The idea is to send a series of missions that would establish a foundational presence on Mars, starting with cargo missions to deliver supplies and equipment. These early missions will focus on creating the essential infrastructure needed to support human life, such as habitats, power generation systems, and life support technologies. Musk envisions a self-sustaining city with a population that could eventually grow to 1 million people. To achieve this, SpaceX will need to establish a reliable supply chain, ensuring that each mission builds upon the last. This means transporting not just people, but also the materials necessary to construct habitats, grow food, and create energy sources like solar farms. The goal is to create a vibrant community that can thrive independently of Earth. Moreover, the plan involves creating a Martian economy. This means utilizing local resources for construction, agriculture, and even manufacturing. Think about it. A thriving colony that can support itself and potentially serve as a launch point for further exploration into the solar system. With each successful mission, we edge closer to turning the dream of living on Mars into a reality. So, as we look to the future, SpaceX's Starship is not just a vehicle. It symbolizes humanity's drive to explore, innovate, and ultimately expand our presence beyond Earth. By the time we reach 2050, we may find ourselves witnessing the birth of a new civilization on Mars, forever changing our understanding of life beyond our home planet. The journey to Mars is filled with challenges, but with visionary leadership and cutting-edge technology, we're taking monumental steps toward making this dream a reality. As we dream about colonizing Mars, another intriguing concept comes to the forefront: terraforming. The process of transforming Mars into a planet that could support human life. This isn't just about setting up habitats and growing crops in greenhouses. It's about fundamentally altering the Martian environment to create conditions similar to those on Earth. Imagine a time when we could walk on the surface of Mars without a spacesuit, breathe the air, and feel the warmth of the sun on our skin. While this idea sounds like science fiction, scientists have been exploring various theories that could make it a reality. One of the first steps in terraforming Mars involves warming the planet. Mars is currently a cold, arid world with average temperatures around -80 degrees Fahrenheit, and it lacks a substantial atmosphere. To begin warming it, researchers propose several approaches. One theory suggests using greenhouse gases such as carbon dioxide to trap heat and raise the planet's temperature. This could be achieved by releasing CO2 from the Martian surface, or even deploying massive mirrors in orbit to reflect sunlight onto the planet. Another critical component of terraforming is creating a thick atmosphere. Mars's atmosphere is less than 1% as dense as Earth's, which means that any warmth generated would quickly dissipate. To build up an atmosphere, we would need to find ways to produce gases that could stay in the atmosphere for long periods. This might involve harnessing microbial life or using technologies to convert Martian resources into breathable air. The idea is to gradually build an atmosphere that can support life and regulate temperatures, allowing for a more stable environment. Of course, we can't talk about terraforming without addressing liquid water. For life as we know it, water is essential. Currently, most of Mars's water is locked in ice, but if we can warm the planet and create a thicker atmosphere, there is potential for liquid water to exist on its surface. One proposal involves melting the polar ice caps and creating lakes and rivers, an ambitious but necessary step towards making Mars a livable environment. However, the journey to terraform Mars is fraught with challenges. The timeline for such an endeavor is daunting. We're looking at hundreds if not thousands of years to see significant changes. And then there are the ethical considerations. Should we alter another planet's environment so drastically? What if there are Martian microorganisms that could be affected by our changes? The ethical implications of terraforming challenge our understanding of stewardship, responsibility, and the consequences of our actions on other worlds. Ultimately, the idea of terraforming Mars invites us to think deeply about our role as explorers and caretakers of the cosmos. It's not just a scientific endeavor, it's a philosophical one. As we develop the technology and knowledge necessary to make Mars habitable, we must also grapple with what it means to transform a planet and how that reflects our values as a species. While the dream of a terraformed Mars may be distant, the conversations it sparks today could shape the way we approach exploration and colonization for generations to come. As we delve deeper into the vision of establishing permanent colonies on Mars, it becomes clear that the journey ahead is fraught with challenges. Colonizing the Red Planet is not just about getting there, it's about creating a sustainable, livable environment for humans. Let's explore some of the major hurdles we need to overcome to make this dream a reality. One of the most pressing issues is radiation exposure. Mars lacks a protective magnetic field and has a thin atmosphere, which means that astronauts on the surface will be bombarded by harmful cosmic rays and solar radiation. Prolonged exposure to this radiation can increase the risk of cancer, damage the nervous system, and cause other health issues. To combat this, future colonies will need to be equipped with effective shielding. This could include building habitats underground or using materials like Martian soil or ice to create protective barriers. Research into advanced materials and engineering designs will be essential to ensure the safety of our future Martian inhabitants. Next is the challenge of food production. While Earth is abundant in resources, Mars presents a different story. Growing food on Mars will require innovative agricultural techniques. Traditional farming methods won't work, given the harsh conditions. We may need to rely on hydroponics or aeroponics, which allow for soil-less farming using nutrient-rich water. Moreover, researchers are exploring ways to use genetically modified organisms that can thrive in Martian soil. Developing reliable food sources is critical not just for sustenance but for psychological well-being, as the act of growing and consuming fresh food can significantly enhance quality of life. Speaking of well-being, we can't overlook the psychological effects of isolation. Living on Mars means being cut off from the familiar comforts of Earth, family, friends, and nature. The isolation and confinement can take a toll on mental health, leading to issues like depression and anxiety. To address this, future missions will need to incorporate strategies to promote mental wellness, such as creating spaces for recreation, fostering community, and maintaining regular communication with Earth. Social dynamics will play a crucial role in maintaining morale, and understanding how to best support the psychological needs of colonists will be essential. Then there's the monumental task of creating a self-sustaining colony. This means developing systems that allow Martian settlers to live independently without constant resupply missions from Earth. We need to find ways to generate energy, recycle waste, and produce water. Solar energy is a promising option given Mars's sunlight exposure, but we'll need to implement efficient storage and distribution systems. Water will need to be harvested from the Martian subsurface or produced through chemical processes. The goal is to create a closed-loop system that minimizes reliance on Earth while maximizing the efficient use of Martian resources. Fortunately, advancements in biotechnology, robotics, and artificial intelligence will be critical in overcoming these challenges. Biotechnology can help us develop crops that are tailored to Martian conditions, while robotics will enable us to automate tasks such as construction and maintenance, reducing the burden on human settlers. AI can play a vital role in managing systems within the colony, optimizing resource use, and even providing psychological support through companionship algorithms. It's essential to recognize that while the challenges of long-term Mars colonization are significant, they are not insurmountable. With the right combination of innovation, research, and human ingenuity, we can turn these hurdles into stepping stones toward creating a thriving colony on Mars. The journey will require collaboration across disciplines and countries, united by a shared vision of not just surviving on Mars, but truly living and thriving there. And as we take these monumental steps into the cosmos, we not only redefine our existence but also expand our understanding of what it means to be human in the vast universe. As we venture into the future of Mars colonization, we must also consider the complex landscape of space politics and economics. The establishment of a colony on Mars presents not only scientific and technological challenges, but also significant political and economic implications. Will Mars become the next great frontier for national rivalries, or can it foster a cooperative global effort among nations? One of the first questions that arises is about space mining. As we've seen with the growing interest in asteroids and the Moon, Mars is rich in untapped resources. Elements like water, iron, and possibly even precious metals could be critical for sustaining human life and supporting the economy of a Martian colony. However, the legal status of these extraterrestrial resources is still largely undefined. Current international treaties like the Outer Space Treaty of 1967 state that no nation can claim sovereignty over celestial bodies. But as private companies and nations gear up to explore Mars, we may face a pressing need to establish new legal frameworks that govern resource extraction and ownership. How will we decide who has the right to mine Mars's resources? And what regulations will we put in place to ensure sustainable practices? The question of governance also comes to the forefront. As we establish a human presence on Mars, we'll need to think about how to govern these colonies. Will Mars be governed by the nation that first sets foot on its surface? Or will we create a new system of governance that reflects the collaborative nature of international space exploration? Some theorists propose models of direct democracy, where colonists have a say in their governance, while others suggest a council made up of representatives from different Earth nations. The decisions made here could set precedents for how humanity manages its expansion into the cosmos. These questions about governance and resource management highlight the potential for both cooperation and conflict. If countries and companies see Mars as a battleground for power and resources, we could face rivalries similar to those seen during the space race of the 20th century. However, there's also the potential for collaboration. The complexities of colonizing another planet might push nations to work together, sharing knowledge, technology, and resources in ways that could ultimately benefit humanity as a whole. The economic implications of a Mars colony are equally profound. As we establish a sustainable presence, we can expect the emergence of new industries centered around space travel, habitat construction, and resource extraction. This could lead to the creation of jobs both on Mars and back on Earth, potentially sparking a new era of economic growth. Companies involved in the space economy will need to navigate not only the technical challenges but also the political landscape that emerges as Mars becomes more populated. The next few decades will be crucial in shaping the political and economic frameworks that govern our efforts on Mars. As we stand on the brink of this new frontier, the decisions we make today will have far-reaching consequences. Whether we approach Mars as a battlefield for national interests or as a shared opportunity for humanity will define our legacy in space exploration. As we push the boundaries of what's possible, it's essential to foster a spirit of cooperation, ensuring that Mars becomes a beacon of hope and unity for future generations. As we fast forward to 2050, let's take a speculative look at what life might be like for the first Martian colonists. Picture this: a thriving settlement, complete with habitats, greenhouses, and research facilities. But what does the day-to-day existence of a Martian colonist truly entail? First, let's talk about work. Martian colonists will likely engage in a variety of occupations, from scientists and engineers to farmers and medical personnel. The economy may center around resource extraction, agriculture, and research, with colonists focused on ensuring the colony's sustainability. Many may work in greenhouses, growing crops that provide food and oxygen, while others might be involved in constructing new habitats or developing technology to improve life on the red planet. Given the harsh environment, adaptability will be key. Expect a culture of innovation, where every day brings new challenges and the need for creative solutions. But it won't be all work, and no play. Recreation will play a vital role in maintaining morale and mental health in this isolated setting. Colonists might find joy in virtual reality experiences that simulate Earth's landscapes or participate in community events that foster social bonds. Think of Martian sports leagues, where teams compete in games designed for low gravity, or cultural nights celebrating Earth's diverse heritage. The sense of community will be crucial in combating the isolation and challenges of living on Mars. Now let's touch on governance. As mentioned earlier, the governing systems on Mars could range from council-based models to more democratic forms of decision-making. Colonists may hold regular assemblies to discuss issues affecting the community, from resource allocation to social welfare. This level of participation might create a strong sense of ownership among colonists, encouraging them to take an active role in shaping their society. However, governance will also need to navigate the complexities of interaction with Earth, especially regarding laws and resource sharing. Surviving in a harsh environment will present its own set of challenges. Colonists will need to deal with radiation exposure, extreme temperatures, and the psychological toll of isolation. Daily routines might include safety drills, equipment checks, and maintaining life support systems. Even the simple act of going outside will involve preparation, donning protective suits and ensuring the habitat is secure. Colonists will likely develop a strong culture of resilience, relying on teamwork and ingenuity to tackle the hurdles they face. Now, what about the relationship between Earth and Mars by 2050? It's reasonable to expect a complex interplay of political, economic, and social dynamics. Mars may have its own governing body, but it will still be under the watchful eye of Earth. We might see trade agreements forming, perhaps Earth supplies luxury items that the Martian colony can't produce, while Mars offers raw materials or research findings that benefit Earth. Politically, Mars could become a point of contention or collaboration, depending on the prevailing attitudes of Earth's nations. Socially, a unique Martian culture may begin to emerge, blending Earth traditions with new practices shaped by the challenges of Martian life. Colonists will develop their own identity, distinct from Earth, which might lead to debates about independence and autonomy. As communication technologies improve, the dialogue between Earth and Mars will likely intensify, fostering connections that keep the two worlds intertwined. Life on Mars in 2050 is likely to be a blend of hard work, innovation, community spirit, and cultural evolution. The pioneers of the Red Planet will not only be carving out a new existence for themselves, but also paving the way for future generations. The decisions made in this nascent society will resonate through history, shaping what it means to be a Martian as we look toward an exciting future beyond Earth. As we look beyond 2050, the question arises, what comes after Mars? The next chapters in humanity's journey into the cosmos are filled with immense possibilities. While Mars may be our first foothold on another planet, it certainly won't be our last. With a successful Martian colony established, the focus will inevitably shift towards the outer planets, the mysteries of exoplanets, and the exhilarating quest for extraterrestrial life. Let's begin with the outer planets. Missions to gas giants like Jupiter and Saturn hold the promise of uncovering secrets about our solar system. These planets, with their complex atmospheres and numerous moons, are ripe for exploration. For instance, Europa, one of Jupiter's moons, is thought to harbor a subsurface ocean beneath its icy crust. Future missions could aim to send probes that drill through the ice to explore this hidden ocean, searching for signs of life. Similarly, Titan, Saturn's largest moon, has lakes of liquid methane and an atmosphere thick enough to support complex chemistry. These intriguing environments could be the next frontiers for human exploration and potential colonization. Then, there are the exoplanets. With advances in technology, we are beginning to discover planets outside our solar system that may have conditions suitable for life. Missions like the James Webb Space Telescope are already providing us with breathtaking views of distant worlds, analyzing their atmospheres, and searching for biosignatures. The long-term goal of humanity could involve sending probes or even crewed missions to these planets, should the technology and resources allow. Imagine a future where humanity can not only visit, but potentially settle on habitable exoplanets, expanding our presence across the galaxy. As we contemplate this expansive future, we must consider the broader vision of humanity as a multi-planetary species. Colonies on Mars could serve as a springboard for further exploration, acting as staging grounds for missions to the asteroid belt, where we might harvest resources or establish bases on larger asteroids. The Moon may also become a pivotal outpost, providing essential support for deeper space missions. Picture, if you will, a network of interconnected colonies across the solar system, each contributing to a shared mission of exploration and survival. However, this journey won't be without its challenges. As we stretch out into the cosmos, we'll need to grapple with the ethical implications of colonization, the preservation of extraterrestrial environments, and the potential impact on any existing life forms we may encounter. The choices we make today will shape not only our future but the future of the cosmos as well.